Okay, we're ready for our demo, Bob.
Is he still awake?
He's right here. I can see him in the little picture. Okay, this is Bob Behnke. He works for Titebond, and he's one of their glue chemists, right?
Yeah, I'm actually technical service manager, but I do have a degree in chemistry. So if I get a little too technical, somebody's got to rein me back in. So
I'll have to turn it over to you. You can tell us a little bit about yourself if you will, and then whatever.
okay, and then we'll have to do a screen share. So I'm a technical service manager for Titebond products. We manufacture all of the Titebond glues here in Columbus, Ohio. Can you guys hear me okay out there?
Yes.
Yep.
Okay. So part of my group, basically my business card is on the back of every bottle. Let me grab one here. There's a 800 number on every bottle of glue that rings to my group. So if you needed to talk to me, you can always ask for Bob. I'm the only Bob who works in the group. But we have two people who answer phones full time, and then we have two people who do laboratory testing. So we'll test competitive products and make sure that we have some of the better products on the market. So we'll test for that. We're going to focus on basically wood today. We do manufacture adhesives that do bond to plastics and roofing materials and things like that. But we're going to kind of focus on wood and comes in many different varieties, strengths and everything. And so, but there's various properties of wood that can affect how it glues up. And so we're going to kind of go through there. Again, this is not going to be just a presentation. I want to take questions. So if you guys have a question, just blurt it right out. It's better for the group if we have questions, because then it's things that are of interest to you guys instead of me just spewing out information for you guys. So let me know if you have any questions along the way.
Okay.
So one of the things we want to look at is wood density. And wood density typically is proportional to the strength of the wood. And most of the time we'll get questions here asking about, okay, so what is your strongest glue? And really it doesn't matter. And I'll kind of give you an idea. So this one person called, said he needed my strongest glue. I said, well, what are you putting together? And he said, I'm gluing together balsa airplanes. So my statement to him was, with balsa, you really don't need my strongest glue. My strongest glue will be our new one that we have out. It'll go up to 4,100 PSI. But the issue is balsa breaks at somewhere around 80. And so in that particular case, what we look at as adhesion chemists, what we look at is that chain of adhesion, right? So I bond to substrate A. The glue then has a attraction property to substrate A. Then the glue itself has a bit of strength. And then the glue has an attraction to the second substrate B. And then substrate B has a certain strength also. So what's going to break is typically the weakest link in that chain. And in most cases, that's going to be the wood and not the glue. Now, if you're using some of the more dense hardwood tropicals, that may not always be the case. Some of those are very strong. And in some cases, the glue will break under some of those circumstances. So again, most of the domestic hardwoods that you guys are using, typically are going to break from 1,000 to 2,500 PSI. So again, you don't need my strongest glue. You just need a glue that's going to hold your pieces together under the stresses that those projects are going to be put under. Okay. The other thing we want to talk about is moisture content of the wood. So when you're using a water-based wood glue like Titebond Original, Titebond 2, Titebond 3, if your wood moisture is above 17% moisture content, the glue will not dry. And normally we'll get a couple of calls and people go, I just bought your glue. I used it. I put it in my project. I've clamped it up for 24 hours and the glue's just not dry. Something's wrong with the glue. And my statement to them typically is, well, all it is glue, and I'll have some pictures of what it looks like under a microscope. So it's just little balls of plastic that float in water. If the glue is not drying, that means there is no place for that water to go. Laws of thermodynamics would state that things will go from areas of high concentration to areas of low concentration. At 70% moisture content, wood will be happy with all of the water that it has and doesn't really want any more water. And that's typically what's going to happen. Because if you actually have found a way to keep water from evaporating, the Saudi Arabians would love to talk to you guys. But tell me first, because we're all going to get rich together. So normally when you see us give out information on how the glues work, we test everything at about 8% moisture content. We test at 70 degrees Fahrenheit and 50% relative humidity. Those are laboratory conditions. So therefore, excuse me, therefore, if your wood is higher moisture content, that means all of our, if we're talking about open time, working time, that's going to be extended. If your wood is drier than that, then it's going to be a lot shorter than that. And so just a note, if you don't know what your moisture content of the wood is, and in some cases, we're not going to be able to help you in answering some of the questions that you may have. The other thing we want to talk about is with wood is that it doesn't expand and contract equally in each direction. So if we're looking at the, say the base of the tree to the top of the tree, the movement in terms of moisture content is very negligible. So the tree does not shrink, or the wood does not shrink in that dimension very much. When we look at the direction from the middle of the tree to the outside of the tree, and that's called radial dimension, it shrinks, say, X amount. And each tree, each species, where it's grown, that will differ with each of them. But when we look at tangential direction, which is the circumference around the tree, it's going to shrink 2x. And what that means is, when you see a log, say on the side of the road that's drying out, normally you're going to see it split this way because the log is shrinking a lot more in the, I'd say the radial or the tangential direction than it is from the middle of the tree to the outside of the tree. And so therefore, there's much more movement there. And so then the wood is going to crack. And that movement is so strong that the wood will not be able to, resist breaking from that movement. And so when you're planning your different projects, you have to understand what the moisture changes it's going to see, what dimensional changes it's also going to see. So one of the things that we get a couple of calls on, can you see that now?
Yeah.
Okay, so let me go back to the couple of slides that we had. This was the one on density I was talking about. This was the one on moisture content. So we're on this one right now, and you can all see that, the log and then the twist and the cups and the crooks.
Yes.
Yes, we can.
Okay. Okay, so one of the things that we see is that some people will call me and they'll say that the wood is extruded from the glue line. Well, a couple of things can happen with wood. Let's say I've glued 2 or 3 pieces of wood together. The 2 on the outside are 6%. The middle one is 10%. Eventually, over time, that wood is going to equalize in terms of moisture content. So what's going to happen is that board in the middle is going to be smaller than when you first planed it or sanded it down. And so you'll find that you get a step joint in those particular cases. So again, you want to make sure that when you're putting your wood together, you're gluing wood together, that they are considerably equal in moisture content. This can happen with miter joints too. With a miter joint, say on a picture frame, if the wood shrinks from where you put it, then it's going to open up the miter on the inside. If the wood grows in moisture content, it's going to open it up from the outside. So again, it will differ. Now, in this particular picture, it shows plain sawn wood, where you have the cathedraling down the boards. In this particular case, remember we talked about tangential growth being higher. So along those, along the growth rings, it's going to move more than, say, the thickness on this particular board, because the thickness on this particular board on a plain stone board is going to be the radial direction, which is X, but the tangential direction is going to be in the width of the board, and that's going to be 2X. So in a lot of cases, plain stone boards will tend to cup because the inside of the rings don't shrink as much as the outside, because there's more grain on the outside than there is on the inside of that panel. And so they tend to cup. And in a lot of cases, that's why, say, if I'm making a tabletop, I'll repeat or make it opposite of the growth rings on each of them. That can sometimes give you a little bit of a wobbly look to your tabletop. Or if you do it all in one direction, then you get more of a curvature, but then you've got to work with that. So again, we want to realize that we're working with wood that is going to move, and we have to plan for that movement. The other thing we want to look at is if you've got rift or quarter sawn wood, then the boards will change in thickness more than it will in width, okay? And that can make an issue when we look at sunken glue joints. So a sunken glue joint, this is where we'll get calls and people say, well, I'm feeling a ridge of glue, so the glue is extruding out of the glue lines. Well, everybody has, how'd you say, scraped wood glue once it's dry. It's pretty hard plastic. And unless you put a lot of pressure on wood, laws of physics would state that my glue is not going to squeeze out of the glue line unless you put a lot of pressure there. So what's happening, and you know, if anybody's a segmented wood turner, you'll kind of get an idea of what I'm talking about. So when you first glue something up, it's going to swell the wood around the glue lines. If I then take that and sand it before the wood has a chance to dry back down, then what's going to happen is the glue lines are going to shrink at a later point. And in that case, the problem is PVAs or polyvinyl acetate wood glues, the plastic glues don't shrink when they dry. And so therefore the glue lines will feel like they're proud of the surface. But if you took a straight edge, those lines would be at the top of that either planed surface or where you've sanded it down, okay? Now, the other thing can happen just normally, and this is where quarter sawn wood tends to be more reactive or have more movement in this particular case. But if you start with 10% wood and then it dries out, again, those glue lines can then be proud of the surface, and you can actually feel it. And in a lot of cases, say if you were a segmented wood turner, you've just sanded your piece on the lathe, and it feels silky smooth, right? I mean, everybody feels that. It's that, wow, this feels really good. Then after you take it off and it's been sitting around a couple of weeks, you take that same piece and you feel it in your hands, and you can actually feel a lot of those glue lines. And in some cases, those pieces that were kind of rounded are no longer rounded. Some are, you know, kind of caved in a little bit. And what's happening there is just the moisture content is changing on that wood, and that's normal. But you want to be prepared for that. And if you were looking to, make sure that it feels good all the time, you want to dry that piece out to about 4% moisture content. Then you want to put it on your lathe, sand it down, because the human finger will feel things proud of a surface. But if it is a sunken area, your finger typically will ride over that and will not feel that. Okay? Questions at this point?
So that was 4%?
Yeah, 4% typically in most areas of the United States, you're not going to get below 4% moisture content in wood. Now, in some cases, we have seen in Minnesota, dead of winter, January, if they're not putting any moisture in their house, sometimes the wood can get down to 2%, but that's very, very rare. And in a lot of cases, a 2% change from 4 to 2 doesn't make a whole bunch of movement in most of the domestic hardwoods that you're going to see.
Since you're talking about segmented stuff, is there any way that when you sand it, let's say at a high speed versus a low speed, that you can do anything to affect that joint?
Well, so the wood glues themselves will tend to melt at about 250 degrees. So if you get a temperature up that high, you can, in some cases, cause some of the surfaces of the glue line to melt a little bit. But that's usually not a big issue.
Thanks.
Does that answer the question?
Yes, thanks.
Okay. So the other thing we want to look at is with wood is, since as trees grow, they can't move around to get away from bugs and things like that. What they end up doing is producing chemicals, that's their immune system, so to speak, to keep viruses, bacteria, and bugs from eating the tree. Since it can't move away from those sites, it has to, basically it's chemical warfare. And those chemicals, tannic acids and things like that, if you ever have boiled a couple of pieces of wood, they can turn the water very brown. You can get a good idea of what some of that stuff is in the wood. But one of the things that kind of surprises woodworkers when I tell them this is that wood glues do not bond through the mechanical bonding and locking of pores in the wood. Now, I can absolutely give you an example of that, because if that was the case, if bonding through the pores of the wood was the main cause of adhesion, end grain to end grain bonding would be your strongest joint. That is not the case. What wood glues bond to is cellulose. And being a chemist, I'm going to show you some chemistry stuff, so hang on. So those oxygen-hydrogen bonds, the OH groups, they act as little neodymium magnets. So an oxygen loves to grab an electron and hold it tightly, and hydrogen likes to give it up. Don't want it, you can have it. So what ends up happening is those oxygen-hydrogen groups, and this is really what makes a lot of the chemistry of biology work, is that the oxygen will pull an electron towards it and get a net negative charge. The hydrogen then ends up with a net positive charge. And so we, at this point, have tiny atomic magnets that are formed. And because of that, the hydroxyl bonding or hydrogen bonding occurs where the hydrogen kind of likes to nestle up near that oxygen, and the oxygen likes to nestle up again to the hydrogen. And so you get this like little clicking together of these little magnets, and that's what keeps the bonding of the chemistry strong. Okay? And so what we want to look at is anything that causes the glue not to be able to bond to those hydroxyl groups on the cellulose will cause the bonds to become weaker. Okay? So if you're looking at a tropical wood, right, where the water beads up on there, you need to wipe that oil off because the oil is protecting the cellulose from bugs that want to eat it. And so to do that, we actually recommend using acetone instead of mineral spirits or alcohol, because those can actually cause the wood to absorb some chemicals, which then will help to mask the cellulose. Acetone tends to dissolve any of the chemicals that is in a tree, any resins that are in there, any tannic acids, all of those can be removed with acetone. The problem with acetone is it does evaporate relatively quickly. So what you want to do is take a white rag and keep wiping until the rag comes back clean. And as you see in the picture down below, if you're still getting that yellowish color off, that means you're getting chemicals off of the surface of the wood. Those chemicals are protecting the cellulose, and any of those chemicals will cause your bonds to be weaker because the glue can't get to enough cellulose. It's kind of like I can stick one neodymium magnet to my refrigerator and I can pull it off pretty easily. If I get 1,000 of those on the refrigerator and pull all at one time, I'm actually going to move the whole refrigerator, right? And that's kind of what we're looking at here. You want to optimize the amount of cellulose that the glue is getting into contact with to gain your strongest bonds. Okay? Now, the other thing that can happen is you can run into issues with contamination in the wood. PVA glues will release acetic acid. That's the acetate group hydrolyzes off of the polymer, forming acetic acid or vinegar. If there's any iron ions that are in the wood, or that you've sanded something with that has iron on it and then sanded the wood, those iron ions will turn into a black dye. Everybody has anybody ever taken steel wool with vinegar to make kind of a black dye? This is the same process that is occurring in the glue line. So we want to just make sure if you're getting dark black glue lines, there's iron somewhere. And now I may not be able to tell you where it is, but I can tell you that it is. We have heard of some glue lines turning green. No one has sent us any of those samples to test. If you guys do run into any glue lines other than black, we know black is iron. I've heard of red, pink, green. So just note that if your glue lines are turning a different color, it's probably because of metal ion contamination. If you do run into that, a couple of things you can do to solve that. One is you're going to need to get different wood. A lot of oaks sometimes will pick up iron from the soil, and that tree, basically wood from that whole tree, is going to do that. Otherwise, you can change from a PVA. You can go ahead and use either an epoxy, or you can use a polyurethane glue, and that'll solve the problem also. So, and that is the reason. So edge gluing to edge gluing has a lot of cellulose there. And so that's why most of your joinery that you look at looks at optimizing that, how do you say, that face grain to face grain, whereas like a miter joint, which has a lot of end grain characteristic to it, tends to be relatively weaker because there's just not a lot of cellulose there to bond to. It's kind of like bonding to the ends of straws. And so that's kind of the issue that you're going through. Questions at this point?
No.
Okay, so let's look a little at clamping, right? So the objective of clamping is to hold the wood together without gaps, right? Now, if I've got two pieces, what we look at, where you put the clamp, you're going to get a 90-degree, what we call the cone of force off of the clamping pads, right? So you want to make sure that your forces are overlapping to make sure there's no dead spots in your wood. If I've got a thinner piece of wood, I need to either put more clamps on there, because I'll have places where pressure will not be, how do you say, present on there, and the wood, as it absorbs water from the glue, will twist and warp a little bit, right? And so in that particular case, I would add a caul to the top of that to spread that load out a little further. And that gives you pressure. Now, what is the optimum clamping pressure? So we did an experiment here to find out what that would be. And what we did, we actually had a guy call. He was using Jatoba. He was utilizing our recommended clamping pressures, and he was having problems with the joints. So we had him, he sent us some of his Jatoba that he was using, and we ran some testing. On that testing, we took three different pressures. One is where we took just a 5-pound weight and we put it on top of the pieces for gluing. That worked out to be about 0.6 pounds per square inch of clamping force. Then we used our recommended forces, which is use 100 PSI for softer woods, 150 PSI for medium density, such as like maple oak. And then we ran some of the Jatoba, which is a high density wood. and we ran that all the way up to 1,000 PSI in a carver press. And then we used poplar, maple, and then the Jatoba, 3 different hardnesses of wood. And what we found was that the highest strength was always achieved with the 5-pound weight. And so what we've done is we've actually changed our recommendations for clamping from our standard of 100, 150 to 100, 150 to 200 PSI. And now we say just put the least amount of pressure that you can on your pieces to get them into contact during that drying process. Now remember, during the drying process, that wood is absorbing water on one part of the wood, and that wood is going to grow just as we discussed, right? And that's going to be different versus the radial direction versus the tangential direction versus the latitudinal direction, right? And so we want to be cognizant of the wood movement and clamp it with enough force so that as though that wood absorbs water, it's not going to move, right? Because if the wood moves at that point, as the adhesive is drying, it can break that glue bond and then it won't form. And we'll talk a little bit about drying of the adhesive next. So you never want to crank down on your clamps thinking, oh, a little pressure is good, more pressure is going to be better. It's actually the opposite of that. So just be cognizant of that when you do clamp up your work.
How would one measure 100 PSI of clamping pressure? Because all I use is my wrist, so.
Well, you can actually take a bathroom scale, put it between 2 pieces of wood, and then start cranking down on your clamps, and you'll get an idea. I mean, there really isn't a great way of doing it without having a lot of like a carver press or something like that, right? So, but you want to get kind of used to that. What kind of pressure am I putting on there? But really, it doesn't matter, because what you're looking for is to put the least amount of pressure that you can and keep your parts together. Does that make sense?
Yeah.
So the old saying is, when you're clamping 2 boards together, you still want to clamp it till the glue comes out?
Yeah, you want to make sure that you have enough coverage. And we'll kind of go through one-sided or two-sided gluing. I do have a slide on that. But if you're a single-sided gluer, you do want to make sure that you've got some squeeze out. And even, it's going to be the little tiny pearls, but you want to make sure you got squeeze out just to make sure that you've covered the whole surface. Two-sided gluers don't have to worry as much about that because they're making sure both sides are covered. So, but yeah, you should have some squeeze out. So we're going to talk a little bit about glue drying now. And basically, all the glue is, and this is an actual picture of Titebond original. Okay, so basically all it is, little balls of plastic that float in water. And there's different particle sizes in there, but basically that's it. It's not rocket science. And all that happens when it dries, these little particles get closer and closer and closer together until they touch, right? So when they touch, and everybody's rubbed glue between their fingers, right? I mean, initially, so basically everybody's rubbed glue between their fingers, and it's real slippery, right? And so as you're rubbing it, it kind of gets to what I call a putty point, right? Where it doesn't slide anymore. At that point, all those little particles are now touching and therefore can't flow any further. At that point, you cannot take that glue that's on your finger, wipe it onto a board, and then press it together and have it bond. It will not bond because the glue cannot flow and get into intimate contact with the cellulose. So on the outside of each of those particles is going to be a layer of what it's called polyvinyl alcohol, which has a ton of those same hydroxyl groups, those OH groups, that are then going to bond to the cellulose. But if the little particles can't flow, then you're not going to get intimate contact with the surface. And just like a magnet, which is, I mean, if you got, say, a couple of pieces of paper between the magnet and the metal, it's easy to pull off because it just can't get close enough to form a strong magnetic bond. Okay? So where is that putty point? How much evaporation has to occur to get there? Well, most of the wood glues are about 50% solids. Some of the faster setting ones will be 60% solids, but we'll talk about 50% solids. And before they start to touch, theoretically, let's say if I got a jar with marbles packed in there, I can still add 33% water. So that putty point's going to come at about 67% solids. That means I only have 17% of the water to play with. Once that water's gone, the glue is going to be set. Now, it won't be extremely strong at that point, and if I pull the bond apart, then the little balls of plastic that have been touching get pulled apart, and I introduce air in that glue line. That air will cause it to kind of be like a foam, and that foam is always going to be very, very weak. Okay, so your glue lines will get weak. So we have what we call open time and total working time for each of our glues. The open time is the time where you spread the glue onto the wood and two things are occurring at that point in time. If the air is not at 100% relative humidity, you're going to get evaporation off of the glue surface. And once the glue surface dries and gets to the putty point, when I put two pieces of wood together, that glue is not going to flow onto the second substrate, right? So if I'm a single-sided gluer, I've got to get that glue on quickly before the surface dries, and I got to get my pieces together and kind of rub them to get the glue to flow onto the other surface. Okay? The next thing that we're going to look at is the total assembly time. So once the glue two pieces are together, now the wood is also soaking the water out of the glue. And everybody's spread glue on a piece of wood, and the glue gets draggy right away, right? So that dragginess is that the glue has already gotten to its putty point as soon as the glue hits the wood. So I get a layer of glue that is actually puttied up on the surface. So I have to add a little more glue on top of that so that that glue now is has more moisture in it and flows across that surface, right? So that total assembly time is the time where now that I've got my two pieces together, I got to get the clamps on before the glue gets to that putty point in the middle of the glue, because then when I clamp, I can't clamp without those two pieces moving relative to each other. I mean, it only has to move half of a particle, which is 1,000 or a millionth of a meter, for it to introduce air into the system. So you got to make sure that the glue is flowable enough to reform as those glue lines break as you're clamping it up. Okay, so how many of you guys, I'm not seeing the picture of the group, but who's a single-sided gluer? Raise your hand. Okay, who's a two-sided gluer? Raise your hand. Okay, what I can tell you is everybody is correct. Okay, there is no right answer or wrong answer to that. There's just advantages and disadvantages to each one. So the only way to get invisible glue lines is to be a single-sided gluer. And the reason for that is as soon as that glue touches the wood, I'm forming a glue line. If I put glue on both sides, I'm forming two glue lines at the same time, and my glue lines will always be twice as thick. Okay? But the problem with being a single-sided gluer is that there's not a lot of water that I'm playing with. I don't have a lot of glue. And so what happens is I got to get my glue on very quickly. Two-sided gluers, on the other hand, are assured that they're going to get glue on both sides. And in most cases, unless you really leave it open for a very long time, you're going to be assured to have, wet glue in the middle that's still going to flow. Now, what happens is you're going to use twice as much glue. You're going to get a lot of squeeze out. And by the way, our company thanks you for that. But just note that in most of those cases, as a two-sided gluer, you're pretty assured that that's going to be a pretty strong joint, right? Because it's very difficult to get past that the total assembly time, because there's just so much water, right? And so if you are looking for more time to glue something up, you can do a couple things, right? Now that we know how the glue is drying, we can wet the wood, moisten the wood before we put the glue on, right? Because we remember from one of the previous slides that at 17% moisture content, the wood doesn't want to take any more water. So once you get the wood up to 17% moisture content just on the surface, it's not going to want to suck any more water out of that glue. The other thing that you can do is take a humidifier, blow humid air around your glue up area, form a microclimate over your gluing area of relative humidity around 100%, and the glue's not going to evaporate. So you can really increase significantly the amount of time that you can to put it together. But the other thing that you have to remember is you've now just put a lot of water on the wood, and that's going to take a lot longer for it to dry, which means, remember we talked about the sunken glue joints and all of that, which means you're going to have to wait a little bit longer for the glue to set, right? And because the glue doesn't dry if the wood's at 17% moisture content, you got to leave it clamped up for a longer period of time also. So there's no perfect, what I would call, scenario in this. Single-sided gluer, you got to worry about time. Two-sided gluers, you got more time, but then you got more squeeze out. You wet the wood to get more working time, then it's just going to take you longer for clamping and drying. So it's once you understand the process, then you can start integrating, well, what am I going to need to do for this particular project?
What if you are a single-sided gluer who's very liberal with his use of fluid? So,
and that's fine. That's going to give you a little bit more. But remember, you also have that surface drying on the top of that glue too. You got to get that other piece together, and then you got to wet that other piece out, as you're putting those together. So in some cases, if you get the surface drying and you put your pieces together and you clamp it and you get squeeze out, you really have a layer that was against that second piece that really isn't flowing much and isn't getting you a really good bond. So you got to make sure it's wet on that surface.
okay.
And by rubbing it around a little bit, you kind of break that skin up a little bit and get glue in and up and under. And so that does help wet that second piece out. Okay, so everybody's seeing the edge and face gluing slide right now?
Yes.
Okay, so let's talk a little bit, excuse me. Let's talk a little bit about joint gluing, right? So we need to be cognizant of certain of the joints that we're going to work with and how wood glue is going to interact with them. Let's talk a little bit about a mortise and tenon joint. If I have a tight fitting mortise and tenon joint, I can glue that together with water and it ain't coming apart. Would everybody agree with that? So if my tenon fits real tightly in that mortise, right, as I put water on it, that's going to swell that wood, right? And once I get that together, I'm not going to be able to get that apart. So it's going to stay glued together just through a friction fit for quite a while until the wood has a chance to dry back out. Once it dries back out, the wood then shrinks and then I can get it apart again, right? But let's talk about using a water-based wood glue. So if I use a water-based wood glue and I've got a bunch of these mortise and tenon joints that I'm gluing together, I'm putting glue on there and the wood's starting to absorb all that water. So the tenon is getting bigger, the mortise is shrinking, the size of the mortise is shrinking. And then I take that and I hammer it together, right? What do I do? I've just scraped all of the glue off of the wood. And so now I'm getting a starved glue joint, but it feels pretty good because it's pretty tight because it's absorbed the water. And so in a lot of cases, a tight mortise and tenon joint isn't the greatest thing to use for a water-based adhesive unless you're tapping them together right away. Put the glue on, get them together. For loose fitting joints, let's say I've got a loose mortise and tenon. I put the glue on, put it together. It feels much tighter. But note that the glue is 50% solid, so it's going to shrink as it dries, right? So again, it's going to feel pretty good initially. But as it shrinks, I'm going to get gaps in the glue, which is going to cause possible areas for the forces to build up on some of those areas and allow some movement, right? And as I get movement, any movement, I may break a fiber here and there, and then the next movement is going to break more fibers till eventually that joint loosens up and needs to be repaired. So in a lot of cases, how I tell people is, what I have seen for mortise and tenon joints, sometimes making them just a little tiny bit loose and then fill it with epoxy. And the epoxies don't shrink when they dry, and they'll support that mortise and tenon joint completely. And the epoxies don't allow for the wood to swell because there's no water in it. And so in a lot of cases, an epoxy may be a better, a solution or a choice to do for mortise and tenon. The other thing, let's talk about a dovetail joint. I mean, I've watched people put glue on every single side and piece and of a dovetail joint, and in all of that period of time, the glue's drying, and then they're kind of hammering it together. So when we talk about a dovetail joint, if you get your pins and tails in the correct order, and don't ask me how I know that, but if you get your pins and tails in the right order, this is a mechanically locking joint, right? So most of the force that you're looking at, say on a drawer, is pulling it outward, and that's where the dovetail really is mechanically holding it together. The glue isn't really there to keep the forces from pulling that drawer apart because it's mechanically locked. What the glue is there for is to just tack the sides in so that when somebody's shoving so many clothes into the drawer that it's starting to push the sides out, it just keeps the sides from getting pushed out. You don't need a heck of a lot of glue to do that. So in a lot of cases, understand the joint that you're doing, and what it's supposed to do, where the forces are going to be on there, and use the glue to its advantage, use the joint to its advantage, right? Now, we wouldn't use a miter joint for a drawer, right? Because the miter joint has a lot of end grain there, which doesn't give it a lot of strength, right? And so we don't use miter joints for drawer cases, right? Because you pull it, that miter would come apart. So again, we're thinking about the joints that we have and what the glue can do, because I can glue that together, but even the glue is not going to be able to do what those forces are on that drawer. So that's why we want to look at our joinery and how the glue works in conjunction with our joinery and makes it work. Let's talk a little bit about edge gluing and biscuits or dowels, or what's the other one? Biscuits, dowels, and what are those, the larger pieces? Dominoes, thank you. So in a lot of cases, if I'm doing edge grain to edge grain, if I'm putting dowels, biscuits, or dominoes in there, I've just weakened that joint. A lot of people say, well, what do you mean? Those are supposed to help out. Well, on a side grain or edge grain to edge grain, right? I mean, I'm going to be breaking wood, right? By putting a dowel in there or a biscuit in there, I'm drilling out some wood. And now I've got, if I bend that, the dowel will break through the board at the ends, where the ends of the dowels. And it only has to break through, what, half of the board or less than half of the board, right? Because the dowel has some diameter to it. So I'm breaking maybe just a third of the board before the surface breaks. Whereas if I just glued that together on that side to side, I've got the full strength of the board, or the grain of the board, right? So the dowels and biscuits are great for alignment on those particular cases, but they really don't add strength. They do allow you to get it together quicker for the alignment, which is good for gluing, right? The faster you get it together, the quicker it is. I've had people say, well, when I put the glue on, I'm supposed to wait a couple minutes before putting them together, right? And my statement to you is absolutely not. You get that glue on and you get your parts together as fast as you can, and that's going to allow the glue to flow better and get you stronger bonds, okay? Now, when we talk about dowels and biscuits for end grain to end grain joints, yes, absolutely, they're going to help, because now those are actually adding side grain to side grain characteristics to those joints. So on miters or anything that has end grain into side grain, yeah, absolutely. You want to put dowels in there. biscuits, Dominoes. Those things are all going to increase the side grain to side grain, right? That's the cellulose. Whereas any of the end grain is not going to have a lot of cellulose to bond to. And that's why they tend to be weaker joints. And again, if you look at your joinery is always in the process of trying to maximize or increase the amount of side grain to side grain bonding versus end grain bonding, right? Questions at this point?
Yep. That's good.
So I've got a slide on cold and hot pressing. I mean, most people don't do this. And so I'm just going to pass on. If you've got questions about, veneering and things like that, let me know. We can talk about that later. We've talked a bit about end grain gluing. The best way to glue end grain is basically spread the glue on the joint. And in some cases, depending on the porosity of the wood, you're going to need to put more glue on and just kind of push it into the end grain so that when you do clamp it together, that the glue doesn't disappear from the joint itself. You do need glue in the joint between the two pieces. And it allows for some of the flex and movement of the wood. But you don't have to put the glue on, wait for a couple minutes, and then put more glue on. You just put a healthy dose on there, rub it in with your fingers or with whatever tool you're using to spread it with, and then put it together as quickly as possible. So let's talk a little bit about freezing. And I guess it's getting a little cold down there, even in Texas. Is that correct?
For us, but not freezing, not freezing.
That's what the definition of cold is. We're in
So-
40s, okay?
Oh, okay. Can any of you guys see? Can you see this slide that I've got up? Which slide are you guys seeing?
The one with the larger, yes.
So just the one that says glue application guidelines. When I click on that freezing, does it pull up a picture?
No.
Yeah, unfortunately, you guys aren't seeing a lot of what I'm putting up here. So anyway, I'm just going to have to talk through it. So when you saw the picture of the little particles floating in water, right? And that's water-based wood glues. So when they freeze, that water wants to crystallize, but it doesn't want those particles anywhere near the crystals because that disrupts the crystal lattice. And so what it does is it tends to push the particles away from the ice that grows. And so those particles get pushed closer together. Now note that those particles are glue. They are designed to stick together. And so in a lot of cases, if it freezes and thaws, those particles are kind of stuck a little bit together. So shaking it or stirring it will sometimes break those particles up and the glue is still usable. Now, if you leave it freeze and thaw and then freeze and thaw a few times, the particles get pushed closer and closer together. Eventually, they're not coming apart. Our Titebond Quick and Thick and our other, our speed set, our new product speed set, which are high solids, they're 60% solids, which means there's only 7% water before the particles start to touch. Those tend not to be freeze thaw stable. And that's because those particles get pushed together pretty tightly initially. So my rule of thumb for most of the wood glues is if it comes out of the bottle, you're usually good to go. If the glue's not coming out of the bottle, it usually means it's not a good sign for the glue. It's maybe time to get you a new bottle of glue at that point. One of the other things we want to be cognizant about is the chalk temperature. And I would really love to have you guys see this slide, but unfortunately, we're not going to be able to do that. But there is a temperature on every bottle. Basically, it's going to tell you at what temperature to use it. This Quick and Thick has a temperature of 50 degrees. At a certain temperature, and it's different for each of the glues, it depends on the agents or the chemicals that we put in it. There's going to be a temperature at which if you use it below that temperature, the little particles in there will not melt together to form a film, or what we call coalesce into a film. And they'll remain as discrete particles. And if it's cold enough, your joint will come apart and it'll feel chalky. The glue will feel chalky. In a lot of cases, the glue on the squeeze out will then look very white and powdery. And so that's a sign that you've bonded them at a lower temperature. So you want to make sure that not only your shop is above that temperature, but your wood is also, because normally around this time of the year, we'll get calls from Canada, and normally they start off with, hey, your glue sucks, eh? But it's not really, but it's not really the glue. In a lot of cases, they store their wood outside, they bring it into their shop. Yeah, the shop's heated to 75 degrees, but wood takes a while to get up to temperature. So usually we tell people 24 hours at shop temperature or above that chalk point is going to help you out. So if that ever happens, that your joints come apart and the glue kind of feels chalky, again, that's going to be because you've been glued it up below temperature. The gluing has to occur, then the glue has to dry above that temperature. So your shop may be good, your wood may be good, clamp it up, and then you put it outside because you don't have room in your shop. It probably will cool off if it's really cold outside, and it'll chalk up then. So again, just make sure that it's above there. If you don't have a heated shop and it's really cold, go to Goodwill, get a couple of heated blankets, wrap your stuff in the heated blankets. Normally that's going to work for you, and it'll solve all your problems.
Do you recommend that you store any of this glue in a refrigerator?
So let's talk a little bit about shelf life and storage conditions. So each of the glues will have a shelf life. You really don't care about the shelf life. And the reason why is shelf life is a legal term that we use as a company to protect us from people who want to store our glue in in ways we wouldn't want you to store it. So Titebond Original has a 2-year official shelf life, but with good storage conditions, which is keep it inside, don't let it freeze, don't let it get too hot. I've seen bottles 10 years old still usable. Titebond 2 and Titebond 3, which are water resistant adhesives, and any reactive adhesive, one that gets water resistant, is going to be, is not going to do well in high heat conditions. So Titebond 2 and Titebond 3 still have a 2-year official shelf life, but with good storage conditions indoors, usually about 4 to 5 years of usable life, because that's what you care about. How long is it still usable? Now, if you store 2 and 3 in the refrigerator, I've seen bottles 10 years old still usable. But my question or statement back to you is, if your glue's lasting you 10 years, you definitely need more projects to work on.
What's too hot?
Yeah, you really don't want to store Titebond 2 or 3 in hot conditions, because that'll cut down the usable life. Now, if you're ever unsure about a glue that you have, I mean, it could be 1,000 years old. Take a couple of scrap pieces of wood, glue them together, then clamp them overnight, break them with a hammer. If you're getting wood failure, doesn't matter. That glue is still good. It is still usable for that particular project that you're working on. Right?
What is too hot?
Go ahead.
What is too hot? What's that temperature?
We store our glue at 70 degrees. Anything above 70 degrees to that glue is going to reduce its usable lifetime. If you store it in a garage at, say, 100 degrees, that glue may last 2 years. Titebond 2 will turn into an orange gel and won't come out of the bottle. And don't recommend you even try it. Titebond 3 will turn into a brown gel. Usually it takes a little bit longer for 3 than 2. 2's a little more, it's got a little more catalyst added to it, which causes it to react a little faster. So we've talked about clamping pressure. Again, those were our recommendations for pounds of square inch for holding pressure. Again, in most cases, if your wood's 4/4 or 8/4, you're probably going to be using that amount of pressure to hold them together anyway. But we've changed ours to just say, basically put the least amount of clamp pressure that you need to hold it together. Don't take it at that point and crank down on it and say, more pressure is better, because it is not. The strength will differ between softwoods, hardwoods, and the tropicals. So the softer woods tend to not lose much strength as you go up in pressure. So like poplar, it loses maybe 10% strength, going from that 5 pounds to the 1,000 PSI. The maple lost about 25 to 50% of the strength, going up to the 1,000 PSI. It does pretty well at those you lose only like 5 to 10% at our recommended pressures. But the Jatoba lost 100% to 50% of its strength. In some of the cases, after 1,000 PSI, we took the samples out of the press, they just fell apart. And so you've got to be cognizant of, if your joints are coming out pretty weak, it may be because you're putting a little bit too much pressure on them. Again, recommend that you just put enough pressure on to hold your stuff together. Joint preparation, you want to make sure. So a lot of people will say, I take 80 grit and rough my joints up. That gives it some bite into the wood. The problem with doing that is roughed wood is damaged fibers. And if I glue to damaged fibers, when I go to break it, I get a lot of wood failure. But if you took a strength test on that joint, you'd find that it broke at a much lower strength than non-sanded wood. And the reason is it's similar, and everybody's done it. They've seen a little, a little whisk of wood that's up, and they kind of grab it and pull on it, right? What happens to that? Now I got a big gouge because it follows the grain of the wood down into your piece, right? And that's what occurs with highly sanded wood. You end up pulling on those damaged fibers instead of, strong wood. We recommend having actually the best glued surface is a nice hand planed surface. And the reason for that is, let's say I use a sander and I get too much heat, I can burnish the wood. It doesn't even have to look burned, it just looks polished. Well, the problem with that polished surface is that's what I have to bond to. And the heat has caused the hydroxyl groups, which we talk about on the cellulose, which I need to bond to with my wood glue. They've actually burned all of those off. And now I've got to try to bond to carbon char. My glue doesn't bond to carbon char. Carbon fiber is difficult to bond to because carbon just doesn't have anything to attach to. There's no magnetic properties to it at all. And so it becomes very difficult to bond to. So you want to make sure that the surface is free of any saw marks, knife marks, because that's damaged fibers that I'll be gluing to. And if I pull on those damaged fibers, they can break down into the grain of the wood. We recommend a 220 to 320 grit sand, hand sand actually, because some of the mechanical sanders can actually create a bit of heat and cause some burnishing or polishing of the wood. So let's get into the 5 steps for successful gluing. So the first thing that we want to do is look at doing a dry fit. There's a lot of benefit to doing that. It allows you to figure out how many clamps you're going to need, how long it's going to take you to get your parts together. And that's going to help you figure out, well, what glue am I going to need to use? If I can get it together quickly, Titebond Original 2 are very fast setting adhesives. They tend to set pretty fast. You got 5 minutes of open time, another 5 minutes really to get your pieces together. Titebond Original may give you an extra 10 minutes to get them clamped together, but those are pretty fast adhesives and they set pretty quickly. Titebond 3 is going to give you 10 minutes and then 20 to 25 minutes to get it clamped up. It tends to be a lot more forgiving in terms of the casual user of glue. Now, if you are in a production setting, people in production settings hate Titebond 3 because it just takes longer to dry, right? So though I get longer to put my joints together, I also have to clamp them longer. Whereas with Titebond 3, normally I would say, leave it in the clamps for an hour or two. With Titebond Original and Titebond 2, you can get them out of the clamps in 30 minutes. The strength of that glue builds pretty quickly. So that dry fit should tell you a little bit about how fast you're going to need to be able to go and how long it's going to take you to clamp your stuff up. In that particular case, you can protect get your clamps, you make sure you've got your blocks ready. So you're not yelling because I don't have enough clamps to get this together. So again, it takes some of that stress out of the glue up. In those areas also, once you do the dry fit, you want to look at, hey, I got to sand this thing after. I got to get, that squeeze out of places where, I may not be able to reach once the glue dries. In that case, it's a good time to look at, you can put masking tape on those joints and then take that and then use a razor knife, cut that, and now you got places for the squeeze out onto the masking tape. And then once the glue putties up after about 20 to 30 minutes, then you pull the masking tape off. Just note, use a good masking tape, because if you use a poor quality masking tape, the stickiness of the masking tape can be much harder to remove than the squeeze out can be. So, all right.
How about in turning on a glue block? How long should you wait on the glue block?
So if you're putting, say, rings together or a glue block, I mean, it's going to depend on the moisture content of the wood. So I don't know if I can tell you that specifically. But if you use our quick and thick or our speed set, it's going to set a lot faster because there's just less water that has to evaporate or go into the wood or for drying process. So I would use that. Otherwise, you can always, if you're attaching a block, say, to the metal plate, you can always use a CA glue, and with the activator, that'll cause it to how do you say, set very, very fast. And in a lot of cases, you can hit that metal plate with a hammer, and because the CA glues tend to be rather brittle, that it'll shatter the glue and it'll release relatively easily too. So. Any other questions? Did that help?
The drying times that you mentioned, I don't think I heard the information on quick and thick.
So the quick and thick, it's actually got an open time of 3 minutes. And if you're going to use that as an assembly glue, which I would recommend not, it's more of a kind of a good, how you say, for attaching stuff quickly. You want just one joint at a time with that. You got about 7 minutes to get that clamped up, or it's really going to start drying on you. So that's a very fast setting glue.
And what about Titebond 2 slow?
Titebond 2 extend version. So we have an original extend and Titebond 2 extend version. Those are going to give you 15 minutes of open time. It's got some starch in there to keep the water from evaporating into the air. And then it's got clay in there to plug the pores of the wood so that it doesn't dry as fast. But the issue with both of those is you've got to make sure you mix those. Otherwise, that clay is going to settle to the bottom, and all you're going to be using is really Titebond original or Titebond 2. But that'll give you 20 to 25 minutes, just like Titebond 3 of total assembly time. So the difference between 3 and the extends are 3 is easier to find, for one. We use walnut shell flour in the 3, which plugs the pores of the wood, which gives you that longer working time. So it doesn't settle as much like the clays do in the extends. So the 3 can be easier to use, and it gives you most of the advantages. The only difference is it doesn't have the starch to give you 15 minutes of open time, but it does give you 10 minutes of open time. So yeah, it's a relatively good glue to use all around. I use 3 in my shop just because it's easier for glue ups, because it gives you so much more working time. So. All right. So then you want to make sure that you prepare your glue and your accessories, determine which glue that you want to use. You want to make sure the glue's in good condition. If it's coming out of the bottle kind of gloppy, it may need to be stirred. If you're using the extends, make sure you stir those, because you're going to have mud in the bottom, and it is actually mud. It settles like old paint. And so if you're not mixing those, then you're not really using the extend version of that. Again, if you're unsure of your glue, always test on scrap pieces of wood. Clean up your applicator tips so the glue flows well. The top portion of those clear plastics, they pop all the way off, so you can get a toothpick or a screwdriver in there to clean up any dry glue. So, and the other thing, when we talked about, the iron, make sure that you cover your iron pipes if you're using pipe clamps, because that black stain dives way down deep in that wood and can be very difficult to clean up. So then we want to prepare cleanup items. You want to have some water around. If it spills on the floor or on your clothes, you want to make sure you keep it wet. Again, as long as those particles don't bind together, if you keep them wet, you keep them apart, they're easy to wash out. Once they dry, they can be very difficult to remove. Now, you can always soften, even with dried glue, use a mixture of acetone, water, and vinegar to soften it, and then you can kind of scrape off what's softened, and then you can repeat that process until it comes all the way off. But that's more difficult than, say, keeping it wet initially. So have some water around if you're using a water-based wood glue. If you're using like a polyurethane glue or an epoxy or something like that, get acetone. Acetone works well for that. Mineral spirits, not so much in that particular case. So acetone tends to work better for most of the glues, wood glues that you're going to be using. And then spread some plastic sheeting out just to protect some of the surfaces that you don't want the squeeze out to be getting on. We want to make sure that the shop and the substrates or the wood that we're gluing together are above that chalk point that we discussed. If you can't get your stuff done all at the one time, consider gluing in stages, because you gotta, get an egg timer. If you're a single-sided gluer, get an egg timer. That's all I can say. You really got to be cognizant of that time that the glue has. And then when that timer goes off, you better be wrapping up in a relatively short period of time. Find whatever works for you to spread the glue quickly. Whether it is our tight brush or a credit card with things cut out of them. Spreading the glue fast will help you in terms of getting more time to then assemble your products together. If you're using tropical woods, make sure you wipe those with acetone before you glue up, and make sure that you use a white rag. That rag's got to come back clean. If it's not clean when you wipe, then there's still oil on the surface, and all you're doing is, if you're using that white rag over again with the spot on it, you're just wiping oil around the surface. So get to a new spot, wipe on it until the white rag comes back clean. Then you want to get the glue on right away, because that'll keep basically the oil then from coming up to the surface, because all you've done is you've cleaned the surface, and that's okay, because that's all we're bonding to with the wood glue, to that cellulose on the surface. You're getting the oil out of the cellulose. But there's a whole reservoir of oil underneath there which wants to take its place. Again, things will go from low concentration to high, or from high concentration to low concentration. So that oil that's in the wood is going to move into that area that you just cleaned within an hour. So you want to be able to get your stuff together relatively quickly after you wipe it with acetone. Spread rate is about 250 square feet per gallon. It's probably meaningless to you guys. You just want to get a good spread so that the glue is slippery when you get your parts together. If that means it takes more glue than that, it's okay. You're not going to hurt anything with big, ugly glue lines. It's just there'll be big, ugly glue lines. And in some cases, you can utilize the glue lines as an artistic expression. Any of the glues you can add pigments or dye to. Turn your glue lines black on purpose. And then say if the glue lines are thick enough, it can look like you've got a black veneer in there. Instead, you can paint them red, pink, white, blue, whatever color you want to do, up to 5% pigment or dye. You can use trans tints, whatever you want to use on there. If you want to match the glue to the wood in that particular case, use your trans tints, black, brown, any of the stains or dyes you can add to that also. Okay, and then it's best to peel off any masking tape if you put that on there while it's still slightly rubbery. If you let it dry hard, the tape can be really, really difficult to remove at that point in time. So allow it 10 to 20 minutes, and then you can use a putty knife to scrape off the glue. So remember, we talked about when you get to the putty point of the glue doesn't flow very well, right? So if your squeeze out is at that putty state, I can scrape it off. It'll look like it's rolling all over the place, but it's not going to dive into the wood and cause issues. It's easily sanded off the surface in that particular case. So the good time to remove it is after about 10 to 20 minutes after it's had a little time to dry out. And then after that, if you've had trouble with getting glue stuck in your cap, now would be the time to take the top off, run it underwater, clean it out after it's clamped up. And then the last step, which can be very difficult for some people, is to allow it to dry. Again, my rule of thumb for Titebond 3, 2 to 3 hours. If you're using Titebond Original or 2, usually 30 minutes to an hour, you can take it off. But remember, we're talking about sunken glue joints and all of that other stuff. I would recommend leaving it for several days if you've got a tabletop. And a lot of people say, several days, I got to get this project out. Well, if you wait 24 hours, you're probably going to run into maybe a 50% chance of getting sunken glue joints. If you wait 3 days, that's going to take care of about 85 to 90% of the problems. If you wait a week, I've never heard anybody have issues after a week's worth of that. So just note that waiting sometimes is better before you do that final sand, especially if you're doing segmented wood turning. It's always good to take that piece, set it aside for a while, or put it in your oven and dry it. 150 degrees for a good couple hours. That'll get the moisture content down, and then do your final sand on that, and that's going to leave that nice silky feeling for a larger change in moisture differential. So that's all I have. Any questions at this point?
Very informative.
Well, again, if you guys ever have any questions, again, 800 number is on the bottle. Any questions, we're more than happy to, talk to you about. If you've got some design questions about what joint to use with the glue, et cetera, I mean, we can help you with that too. And again, I'm the only Bob here, so if you call our 800 number, say, I want to talk to Bob, they'll get to me if I'm here.
Thank you.
All right, so I am going to stop my screen share. And that's all I got.
Thank you, Bob.
Thank you very much.
I hope that was informative.